In this video, I'm going to be discussing land bridges, specifically the factors leading to their formation, the methods of disappearance, and their significance. Specifically analyzing or using the Bering Land Bridge, which is this right here. It's also known as the Bering Strait as kind of the case study example. So the Bering Land Bridge existed from about 25,000 years ago to 10,000 years ago. These figures I've drawn are of those time periods, but they're all sort of labeled with their time. All right, so first, it's important to talk about climate cycles. They're very important for understanding land bridge formations because they're often directly connected to ice ages. So there's an interval here, and that goes from the peak global temperature to a local minimum global temperature. This happens cyclically. Of course, now it's kind of exceeding what we would expect the global maximum to be because of human interference, but in the past, we could expect to see this sort of natural shift from high to low, and this low that I've circled right here is about when the Bering Strait was formed, and you'll see why in the next slide. Methods of formation. So I have drawn all of these here so they're not 100% accurate, but they will definitely do the trick for understanding. So this is something known as marine regression, which is basically the melting of the ice caps and then the refreezing of ice caps, which will sort of unearth land bridges. So analyzing the Bering Strait specifically, we'll look at three different time periods. So first, the Miocene epoch, which was 14 million years ago. You can see Earth looked quite a bit like it does today. You can notice the tail kind of coming off of Alaska was a lot longer. There were some strips of land coming off of the east coast of Asia, more islands around Australia, stuff like that. So obviously not 100% the same, but we had a very small ice cap and at the North Pole, a smaller one at the South Pole, and it looks a lot like what we see today. And notice there's no land bridge, so we can connect this in the last slide to one of these global peaks, or local peaks of global temperature. But then 25,000 years ago, around this period right here, we reach a minimum temperature where the ice caps greatly expand as ocean water is frozen. So this whole section right here, which I'll just sort of highlight, all of this is the ice cap of the north. And then the blue right here is ocean water, but the rest is land. And the main thing to notice is this. This is the Bering Strait. This is the way it was formed, was that this little strip of land here existed right here, and existed, it currently exists here as well, but it's just whether or not water is covering it or not. So 25,000 years ago, water was not covering it because the North Pole sort of claimed all that ocean water, so it was unearthed. But of course, at the present day, we can see that, again, we don't have this strip of land connecting Asia to Alaska and North America, so because of our global high temperature. So moving on to another less common method of formation would be plate tectonics, but just the things that we learned in class about constructive forces, which is plate tectonics colliding to create new land or higher land. So when you have one plate here and that's moving this way, and then when it collides with another plate, and this is called subduction, when they ram into each other and one plate dips beneath the other, well, then this causes mountains. And this is how, like, the Himalayas were formed. Mount Everest is basically this subduction and constructive force. From what I've read, there's also some cases where the plates just kind of have this, like, direct clash where one doesn't really dip below the other. That can also create land, but in most cases we see land creation by constructive forces. It's this subduction method right here. So I'll just label these. Subduction. And then talking about the disappearance, which I kind of already covered in methods of formation, we can just see going from 25,000 years ago to the present day, along with the shrinking of the ice cap of the North Pole, all of that water that's released by the melting of the ice will just cover up the land bridge. So it's totally possible that, one day, I mean, it's very likely, and scientists do predict that we'll still eventually reach a local minimum temperature, and then we might see the resurfacing of this land bridge again. But right now, we're at a very high global temperature, so much more ocean water covering up that land bridge. And then its biological and geological significance. Of course, it's more, intuitive to see the biological significance. Like here in this graphic, you can see where humans specifically crossed the Bering Land Bridge into North America. Also, like, several animals did. I mean, this is how, like, camels got to South America. This is how many animals in the Pleistocene, the last ice age, crossed from Asia to North America, was through the Bering Land Bridge. And this was, again, around like 20,000 years ago. But now, of course, we don't see that. Another geological significance is, just like with any sort of plate boundary interference, can be prone to volcano creation and earthquakes. But that's really just something about plate tectonics, and we do see land bridges sometimes occurring along plate boundaries. So that is everything I have. But yeah, basically just covering land bridges, their formation, disappearance, and significance.